All right, so we've got the recording going for the review section for the third exam. Those of you who are seeing this for the first time, the camera is pointed the right way. I want to talk about some of the resources available at the Blackboard site that would be, I think, particularly useful to you. After that, we'll get to working out problems on the board like usual. To get on the third exam, the problems are going to come from Lessons 7 and 8. Lesson 7, Sales and Operations Planning. Lesson 8 on Inventory Management. Right now I've got the on-campus section Blackboard site up. The online students see a lot more at theirs. But there are some resources there as far as examples that you can reference to help study and understand things a little bit more after this review section. As usual, we go to the lesson modules folder. We're in phase 3 now, and we'll start with lesson 7 on sales and operations planning. If you've been there or not, but like with every lesson, we've got PowerPoint slides. I posted the lecture recording here. This is for the on-campus. Posted that again, so if you want to review the lecture part of this lesson, just go and you can watch that. That is essentially me sitting at a desk and talking over PowerPoint slides. But it's a good thing to review if you want to use that. There's a document here. I don't know if this one's all that helpful on general sales and operations planning instructions. It's just kind of a summary of how you would go about attacking the operations planning side of sales and operations planning. Kind of in summary information, the kind of data that you need. I think it's just one sheet. No, 2 sheets. Talks about the basic, sort of the high-level view of the steps for a chase plan, and then the high-level view of the steps required for the level plan. You can keep this off to one side while you work through examples as reference material. May or may not be useful to you. It is there for your use. Then a couple of solved problems. Both of these are posted as the problem itself and then a solution. So the sample homework problem 1, they're all given in Excel spreadsheets. So not because you solve them in Excel, it's just that a spreadsheet's a natural way to kind of present material for sales and operations plan. The most helpful example here is going to be this detailed solution breakdown for homework problem 1. So this is an Excel spreadsheet that does not simply present the solution. The solution to problem number 2 simply presents the solution. But this works through the problem step by step on different tabs in the spreadsheet. So this is something good. I had a student in my fall 2018 section had a hard time understanding a lot of stuff. I gave her some hints, and off of this she said that she could do level to chase planning in her sleep. By the time the class was over, she aced that part of the exam. When you get this particular spreadsheet, you'll notice a bunch of tabs across the bottom, and there's a number of them as we go on through. The first one being just the problem statement. This is a 6-month planning problem as opposed to 4 quarters or 12 months. Now we start out with a level plan. Next tab gives you essentially a walkthrough, so you can talk through / read through on how to solve that. Next tab is a setup, some basic sort of information, and so there's a lot of annotations on this. The annotations themselves in different color, kind of showing where key calculations come from. By themselves, you're probably still scratching your head if you're having trouble with this. Anywhere you see the red triangle in itself, for example here and here, there's a note that's explaining where the calculation or the number came from. Take your mouse cursor and hold it over the red triangle to read the note. And all this is doing for a level plan, because we're planning one workforce level for the entire plan. These initial sort of calculations are figuring out what our net requirement is for the entire plan, explaining where those numbers come from, and figuring out how many employees we need with an explanation of how we figure it out. And then Month by month, another similar sort of thing with annotations on where all the numbers come from, what numbers go together to calculate another number in 1 month of the plan. And again, there's going to be comments in a lot of the cells explaining where these things came from. So this is a good way, if you still have trouble after the review session, to walk through a problem and see how you build a plan out for a chase and a level. So you get a level plan for January, continue that into February, all the different numbers, explaining what a negative beginning inventory number is, level plan for March, and then remember there's more tabs there. April, and then just I jumped to the completion after 4 months, and then an explanation of how the costs come out. So a little more visual, not all words, and hopefully will be useful. As you get beyond that, there's more. So there's the chase plan, an overview, how to do the chase plan for January with comments in all the cells, February. And in the chase, I only show January and February. Once you have 1 month down, you should be able to figure out the rest. And then, finally, the complete solution. So if you're having trouble in sales and operations planning at the end, I think this is a good one. Review the review session. You can go watch the lecture recording again, but this is a standalone spreadsheet that will help explain that. In inventory, I think the biggest thing that is useful is this particular inventory model. It's basically some example problems in inventory with solutions. And so my solutions here, I have tried, in typing up the answer, to step by step and in detail explain why this problem fits this particular model, how to apply the models to solve them. These are problems out of the back of the book, I think almost completely. Some of these give examples of answering questions that we didn't necessarily cover in the lecture. I did hit case lots, what to do when you're trying to order something at one quantity, but your vendor says you have to order in multiple cases. I covered that, but there are some other things that are in these problems that explain. And I think I've done a good job of walking through and explaining everything in here on a number of those problems. Multiple pages to try and go through. So the spreadsheet for sales and operations planning, this example handout for inventory, two good resources, I think, for studying to get ready for this last exam. So here we'll do the usual review session. Come back down to the board. Zoom them out so we can see the whole board and hope that this works as well as it has in the past. We get almost all the board there. And we'll just get going on that. So here in the classroom, everybody's got, I don't have it though, I need an extra. Excuse me. Violating my own rule of walking in front of the camera. Any other extras? As long as I have one, I guess that's all I need. These will be posted if anybody wants to get more of these. So, just a handout with some problems on sales and operations planning and on inventory like you might see on the exam. At the back, you've got a sheet, a formula sheet you can expect to see on the exam. The notation typically will not be there. Most of that notation for inventory models makes sense. Q is order quantity, big D is annual demand, little d is demand per day or week, however the problem is set up. Also at the back is a Z table. It is a more complete Z table than is in the book. The book kind of gives us values of Z and it jumps by 0.05. For Z, well here this jumps by 0.01, but it only gives us values for positive Z. You'll see this on the exam. If all it gives you is values of positive Z, You know that what you're looking for is on this particular table. You don't need the other half of negative z's for any other problem on the exam. So let's move forward. On the first page, a couple of small little problems. You'll see something like this on the exam. Basically, what I'm trying to get here is you have the basic understanding of how to get started on a sales and operations plan without doing a whole plan. The key thing for sales and operations planning is the limited way we're doing it here, and it's limited because we're only looking at full-time employees, hiring and firing them. We're ignoring all the other options. Part-time employees, overtime, temp workers, subcontracting, we're ignoring all that, simplifying it down to full-time workers, and hiring and firing them to adjust capacity. So the two on the first page are simple sort of intro things. Then I've got one problem that starts on page 2, and then tables on page 3 and 4. That will be start working through an entire plan. And on those, I will only ask you to get so far and give me one number. Show me your work up to where you got that one number and then quit. Don't worry about doing the whole thing, just eating up time if you do that. So let's get started on the first page here. So we've got a manufacturer of equipment, and this is a typical sort of an example of a company with seasonal demand for their products. They make a whole bunch of different product lines, and we're focusing in on one product family, barbecue grills for the home consumer. And they're looking to do some planning for the upcoming year. We've got data on demand forecasts, so that's going to be the sales plan, and it's just summary here. Calls for 525,000 grills to be sold in the upcoming year. They start the planning horizon, so before the plan begins, with 28,000 units of inventory, so that's our beginning inventory. Talks about how the manufacturing process works, 10 hours a day, 4 days a week, and they work 50 weeks throughout the year. It's very common in manufacturing around the end of the year to have a couple weeks off, where most people have holiday vacation, and a small crew is going to do maintenance and upgrades and those sorts of things during that downtime. So not 52 weeks. They give us some information on productivity, and for this first one we're looking at a level strategy. And a couple of questions, basic stuff. How many employees? That's the key in this simple sort of a thing that we're doing. How many employees? That will tell you how much you can produce. That will tell you how much is going to be left over each period. That's going to fill out your plan. That's the key calculation here. And then, can you tell me what ending inventory is going to be in the first quarter? I don't give you a worksheet or a table here. I don't want you to use a worksheet or a table here. Just think about it. What's one of the first things we're going to have to do here before we can go and solve this thing?
See how many grills you need.
Figure out how many grills you need, and then the next step is going to be to figure out how many grills you need by taking the beginning inventory off the gross. Then what's the next thing you're going to have to figure out that's going to get you to that key number of employees?
See how many working hours one employee does.
Yeah, what's the output from one employee? It's a level plan. Are we worried about the output from one employee each quarter, or the output from one employee for the entire year? It's the entire year, because a level plan means we want to set an employee level and forget it, keep it level. So we're looking at the whole plan in a level strategy. So we can throw some information up on the board. I didn't call it gross demand, but the problem says it looks like we're going to have demand for 525,000 units. Your gross or your total demand. We always want to figure out a net demand because if we've got some units in inventory, there's no need to produce them. We can just take them off the shelf. The beginning inventory is equal to what, 28,000? And we do the subtraction, 497,000 is going to be your net demand. That's a key number. That's how many I have to produce. Now, how much will one employee give me? When I get the output from one employee, I divide it into what I need total. That tells me how many employees I need. The common error point for students. Having trouble to figure out how to take the productivity information given and turn it into output. And take each unit, takes a quarter of an hour. That's labor hour to produce. So it takes 15 minutes. One worker working 15 minutes to put together or to make this particular grill. What's that? 48 a day?
I said 40 a day?
40 a day? How'd you feel? There's a number of ways you could go about doing this. And I've seen you guys do all sorts of different approaches. All of them will work if you do them right.
Just divided the hours per day for about the 0.25 labor hours it takes to make.
Right, so Zechariah took the 10 hours a worker is working a day divided by the 0.25 hours it takes to make one unit, came up with 40 per worker per day. That's one way you could do it. Other students will look at, well, you'll do it per week or something like that. One worker, 4 days times 10 hours, a number of ways you could do it. If, 40, am I doing this right? Yeah, 40 hours per week. And then you would divide that by the 0.25 hours per unit. If you're big on math and how to flip things around when you're doing division, you'll do this, but we'll talk about how to do this a little differently. You're going to get 160. 160 what? Units of output per employee per, gosh, I'm doing this wrong, aren't I?
You got to multiply that by the week.
Yeah, I'm doing
That's
this.
only for 1 week.
Yep.
I mean, you could have kept that.
I could have kept going, but I have to bounce around and things like that. I could have kept going.
Yeah, 160 times 50, it got you at 8,000.
Yeah, geez, okay, so 40 hours a week divided by 0.25 equals 160 units per week per employee. But we're on a level plan, so we want to know what is one employee going to give me for the whole year. So in this case, we multiply that by our 50 weeks in a year, and 5,000, 5,300?
8,000.
8?
Yeah.
Yeah. Nice round number. So every employee on the payroll, we would plan on that employee being able to give us 8,000 units of output in a year. I need to produce 497,000 units. How many employees? That's what I'm looking for. So we bring this up here and divide it into the total that we need. And that'll tell us how many workers we need. As you can tell, I haven't solved this yet, so I'm asking for your help as we work through that.
62.
That's very close to a round number, but not quite.
62.125.
62.125?
Yeah.
Yep. We need just over 62 workers to be able to produce that 497,000. And we'll just go in with the assumptions here that the basic idea behind the sales and operations plan, give me enough production to satisfy demand across the year. If you round down to 62, you won't satisfy demand. So we round up to 63 employees. And that's the answer to the first part of that first problem. As I go along, if something doesn't make sense, stop me and ask. Because if it doesn't make sense to you, probably doesn't make sense to somebody else. So if we're going to build an entire plan, the number of employees for every quarter would be filled in already as 63. They don't change it in a level plan. Then I throw a little something else in here. Well, let's assume the first quarter demand is 125,000 units. Under this level plan, what would that leave us in inventory at the end of the first quarter? Again, I've got no table or anything up here. Just kind of think about it, how it would work out. I want to know the ending inventory, so what am I going to compare? I'm going to compare my net demand in the first quarter, how much I need to produce, to what I will actually produce from those 63 employees. So the first quarter, now we're down to getting numbers for each period in the plan. We're not going to do a whole plan. First quarter, we have gross demand of 125. We're assuming that. That's given. But again, we got 28,000 already. We don't need that many. That is going to be 97,000 is our net demand. Right now, that's a negative kind of inventory. I haven't satisfied that yet, but I'm going to produce something. It's my actual demand, not actual demand, actual production. Now we got to figure out what are those 63 workers give me in that first quarter. Now I've left out a key piece of information here, haven't I? What's that?
How long is each quarter?
Yeah, how many weeks are in the quarter? For the full year, we take our 52 divided by 4, we get 13. But now we're 50.
What you do by their work weeks though? They got 50 weeks, so what you do?
They got 50 weeks, but in the first quarter, you are those 2 weeks taken off. That, I haven't told you that. Look down the bottom of the page. I say, what happens if they do a level? Yeah, so I should have put that up top. Sorry, I just threw this together today, and I'll fix it before I post it. Actual production, going off of what I gave you in the second half of this problem, 13 weeks, and then I could calculate things out again, but I don't need to because I've already figured out 160 units per worker per week. And if I stop here, I've got the output from one employee in that quarter, but that's not what I'm trying to figure out. I've also figured out I'm going to have 63 employees. So 63 employees producing 160 each week of the 13-week quarter. Punch it on in there. It's not going to be all that far off from 97,000, but it's shouldn't be off by a magnitude 10 or anything. Somebody give me an answer when you got it.
131,040.
131,040?
Yep.
Okay, we got some answers. So 131,040. That's going to be your actual production in the first quarter. Demand, if you look at the numbers, demand in the first quarter isn't all that far off of average demand, but we start with all that beginning inventory in the first quarter. So what am I asking for? What's your ending inventory, right?
34,040.
It's going to end up with 40. 30, yeah, I think you're right, 34,040. That would be your ending inventory. So you ended up producing a little more than average demand that period. 28,000 being your beginning inventory. You end up with 34,000. You're producing an extra 7,040 over average demand. So this is an example of how to get some basic calculations, some short questions that you'll see on an exam, and give me a particular number that we're looking for. Anybody hung up on this? And if you are, what's not clear, what can I help you with? If you don't want to ask, that's fine. You'll have this video posted, so you'll know what's going on. Or at least you go back and take a look at it. So that would be under their current level planning. You've answered some basic questions, but now at the bottom we say, because of the level plan, inventory is going up and down, so they're concerned about their inventory costs with their current strategy of level planning. What would happen if we do a chase plan? So now we want to calculate a number of employees, period by period. Look at what I'm asking down below. How many employees? Again, just the first quarter is what I'm asking for. Based on the numbers and things that I gave you, we can leave this is relevant information. It hasn't changed. We still know that in every week, one employee is going to give me 160 units. But now I want to come up with the number of employees. I can leave this too. To be able to produce enough. I could have left half of that up there too. For the first quarter. So, same basic idea. What's my net demand? Now not for the whole year, but for the first quarter. How much? Divide that by how much one employee gives me, only in that first quarter. That tells me how many workers I'm going to need. And I could do it over there, but I'm going to do a little more processing over here. Still, it's 160 units per week per employee. That doesn't change. Now I'm going to multiply that by 13 weeks. Because that's how many weeks are in this first quarter that we're concerned with. What does that work out to?
2,080.
2,080?
Yes.
2,080? Somebody? Yes. Per worker in that first quarter. That's how many one worker is going to give me. This is how many I have to produce. My net demand in the first quarter is the same as the net demand in a level plan. It doesn't change. Primarily a function of gross demand, sales forecast, and our beginning inventory. We would divide this then by our 2080 per worker. And come up with 40 something, I think.
46.634, and then you just round it up to 47.
46.6 something.
634 or 635.
And again, yep, we're going to round up. Our rule is always produce enough, whether it's over the year or per quarter. We'll round up to 47 employees. Now we're near the level plan, which had us at 63. So this is number of workers. And finally, actual output. Do the same kind of calculation. Yeah, I could have left everything here. 13 weeks times 47 employees times 2080 units per employee will give me my actual output, which should be very close, a little over 97,000.
97,760.
What's that?
97,760.
97,760. Yes? Get some nodding heads here, so it's going to be posted. I want to make sure we got it right. Somebody? They're just trusting you. Is that right?
Yeah.
Y'all are punching in calculators. Somebody nod their head and say, that's right. What's that, right? Come on. You didn't get that? Okay, we didn't get that. Do some more number crunching. Give me the right number. 13 times 47 times 2080.
It's like a A million.
A million? No, I know that's wrong. What did you get wrong?
It says 1,270,800.
I ain't crazy, bro.
That is what I am getting.
Ah, shit.
Shouldn't it just be,
You didn't hear that.
shouldn't it just be
Yeah,
47 times
you guys gotta
2,080?
stop me when I'm messing up.
Shouldn't you just, remove the 13?
Oh, dang it.
I didn't want to say
I
that.
figured out output per worker in the quarter. So I don't multiply that times 13. So now do it and confirm that Alexander was right.
Okay.
You saw me screw up and didn't tell me?
I did all the way before I even looked up.
Okay, you did it without even looking at this stuff.
97,760.
97,760. So, sorry to everybody in video land whose minds blew up when they came up with a million. Whatever.
Right, because we already multiplied.
That's what I get for adding these problems at the last minute and not solving them before I get here. And that's a check for you when you work these things. If you're doing a chase, your actual output should be darn close to the net demand, just a little over. And you should be over by less than the output from one employee, because that overage comes from rounding up from this to this. And so our output from one employee is 2,080, we're overproducing 760, it's a good check. You come up with a million, you know you screwed up. What? Good thing I'm not taking this test. What would be the ending inventory in the first quarter? What's that?
760.
760. I'm not even doing the math. We need to produce 97,000. We're going to produce 97,760. That becomes your ending inventory right there. That would become your beginning inventory for the next period. You would recalculate a net demand in the next period according to the gross demand for that period and just do the same thing again, only skipping over the multiplying times 13. And you do it right. So it gives you an example of the ending inventory differences. In the level plan, what was our ending inventory in the first quarter? 30-something thousand?
34,040.
Yeah, 34,000 something. The level plan, we're going to use that inventory to adjust the variations in demand. In the chase, we don't. Only 760 ending inventory. And if we work the whole thing out, you'd see the changes in employee levels, and we could cost it out and all that. But no need to do that. So examples of little things, small problems that you don't need worksheets for, just think. Key things you want to figure out: how many employees. That's the number one calculation. You get that, everything else flows from it. We will now move to kind of developing a whole plan. You'll also see problem or two where you get some data and a planning worksheet, work through this whole thing. Show me you can get a couple of periods done, and then I'm happy. So I won't want you to do that. So that's our next example here on the second page. It's page 7. This is page 7, number 7 out of the chapter in the book. And you'll notice a lot of text is struck through. So in the book, they're letting you take a problem with all sorts of options for changing capacity and play with it to come up with a plan. I'm not going to ask, can you do a pure chase? Can you do a pure level? That pushes everybody to the same solution. So I cut out all that extra stuff, and we're just going to work with the other things that's not struck through to develop a chase and a level plan here. So I don't know if I'm going to just kind of hairy when I write all this up on the board. I may do some pre-processing and then just bring up this document. Now I'll work everything on the board since the camera's already here. So the worksheets are before, so I'm going to start filling some stuff in here with the basic data. Again, a 4-quarter. I'll tell you now, your exam problems are 4 quarters. I keep things relatively small. I'm going to do some pre-processing. I'll put that over here. The output per employee and the wages, the output per employee useful in developing the plan, the wages, useful, and costing out the plant. And we'll get to that. We could do that. And then the basic plan. So we've got gross demand at the top, beginning inventory, and I'll fill in the rest. So this is a good chance if you want to slip out of the review session. Net demand, same thing as net requirement on the handout. Number of employees, and we're not going to do the fractional, we'll just round automatically up to integer. Actual production, on the handout it's called total actual production. Hired or fired if we're going to do that, in ending inventory. A typical sales and operations planning worksheet. And so we'll start working out this problem. We'll do some pre-processing on the left side before we come out and fill in the table. The gross demand 10,000, 8, 7, and 12. Our beginning inventory, if you read the problem, says we have 500 units. Our number of employees, off to the left, I'll write the beginning number. The problem says 30, correct? 30. So we can use that to figure hired, fired in the first period. All right, so I know my net demand in the first period is going to be 9,500. Both plans can be set up this way. And so the first spreadsheet talks about a chase approach. So unlike the first problems we looked at, we'll start with chase and then move to level. So quarter by quarter, determine how many workers you need to produce at least the net demand in that quarter. Any excess production is carried over. So now we need to do that pre-processing, or it helps up over here on the output per employee. Read the problem, let's see what's going on. A lot of costs and everything. Assume the worker productivity, 1/2 unit per worker hour. So that means it's going to take 2 hours to produce 1 unit. 8 hours per day and 60 days per season. Hey, so we don't have to calculate output and wages quarter by quarter. We're just leaving it at 60 days in each quarter. And let's do some output calculations. 60 days in a quarter. They're working 8 hours a day. So each worker is going to work 480 hours in the quarter. What does that mean as far as output? It says it takes 1/2 unit per worker hour. That's what we get out of our workers. Do I multiply 480 times 1/2 or divide by 1/2? I got to divide over here. What about the rest of you? You got to make a decision, so make the right one. I got to multiply over here. We're going to bring you up front. We're going to wrestle if we get the right answer. I don't know. He's kind of big, and he's got the wrong answer, unfortunately. If you divided 1/2 into this, you'd come up with 960 units. But the problem says, read and understand, you only get 1/2 unit produced per worker hour. So think, that means in 2 hours, I'm only going to get 1 unit. So in this case, you would divide by 2 or multiply by 1/2. So stop and think. I'm getting less than 1 unit per hour. So my output's going to have to be less than 480. So and you can try it both ways. You could have done it your way, say 960, hell no. I got to do it the other way. And if you wrote it out the good old-fashioned math way and canceled things, you would see the hours would be on the bottom for one, on the top they would cancel out, which is what we want coming out. So in this case, it's 240 units per employee per quarter. So if you having trouble figuring out, the first thing you should ask yourself, am I getting more than a unit per hour or less? And if you know that, then divide and multiply and pick the one that's right. That would make sense here. So output per employee is 240. And I could just, write that across, 240. I've got the thing to do wages. If the question doesn't ask about wages, don't worry about it. And if the question asks, what are your labor wages going to be, well, then you'd have to figure this out. So let's assume we're going to figure this out. Wages over here, you don't need formulas or a book to tell you. Every worker is going to put in 480 hours a quarter, and we pay them, wow, $5 an hour. We're illegal, but okay. Show me the age of the book. It is. Just try and tell the authors to update these things and put some real numbers in there. But we still have this old number of $5 an hour. 2,400. Yep. So every worker is going to be paid $2,400 a quarter, and then they'll report us to the government. Or maybe they're undocumented and we're abusing them. That's a bad thing. Our ethics would say we shouldn't do that. We'll go with the numbers that we've got here. So pre-processing of data, jumped through. I've left some white space on here. Basically, days in the period, 60 times 8 hours. And here we are multiplying by the units per hour. We got the 240, and then the wages. Days in the period, 8 hours per day. Well, we already did that. That's $5 an hour. And then we'll just work through. Now that we've got that, we can build a plan. It's a chase plan right now. The number of employees, you got to figure period by period. And I'll go through, we'll get to beginning inventory for spring and we'll just stop. Because on an exam, I'm not going to make you do the whole thing, and we have a limited amount of time for this particular review session. So how many employees do I need? I have to produce 9,500, and each employee is going to give me 240. And then I'm going to round up. So if I take that division and round up, I get how many employees? I really should keep a solution with me here, but good. You guys at work, it keeps you awake. Anything, Anna? Typing?
Rounding it up.
40?
Yeah, 40.
40?
Yeah.
40. Okay. 39 point something. We'll round it up to 40. Is this spreadsheet just, what's the actual integer number of employees? Because we're rounding up the number of employees, we're going to get a little more than 9,500. Our actual production is 40 times 240. That's 9,600? That was a question. Someone help me?
Yes.
Yes. And again, it's a good check. Our actual output should be a little more than net demand by less than the output of one employee. Yeah, it's a little more by 100 units. That's less than the output from one employee. Did I have to hire and fire? We started with 30. We're going to go to 40. We're going to have to hire 10. No formulas for this. Therefore, we're not going to fire anybody. And our ending inventory is a difference between what we actually produced and the net demand, 100. 9,600 minus 95. Ending inventory at any one period becomes your beginning for the next period. Gross demand of 8,000 in the next period, beginning inventory of 100. I need to come up with 7,900. My demand is dropping, therefore my workforce is going to drop because I won't need as much capacity. My workforce then is gonna be 7,900 this time, divided by the same 240. That is gonna be 30 something, I don't know, when we round up.
33.
33? Yes?
Yep.
Yep. Yep. And our actual production from those 33 employees done the same way. Gonna be, I don't know what that's gonna be. 80-20, what is that?
7920.
79-20?
Yes.
Hired or fired, here's, students get hung up by continuing to look at our starting workforce. Doesn't apply anymore in the second quarter. We're going to the prior period when we had 40 workers, we're going down to 33, so we're not hiring anybody, but we have to fire 7. You start seeing the problem with a pure chase approach, is you keep screwing with your workforce from period to period. Actually produced 7920, we only needed 7,900. 20 is our ending inventory. In the second period, that becomes our beginning inventory. For the third period, gross demand of 7,000 minus 20, that's going to be beginning on hand, going to give us 6,980. Number of employees to produce 6,980. Again, demand drops from the prior period, so our workforce should be dropping.
30.
30? 30?
Yes.
Yeah. It would be 6,980 divided by 240. You get 29 point something. You round to 30. 30 times 240 units of actual output is going to equal
7,020.
7,020?
200.
7,200. We went from 30 in the second quarter to, 33 in the second quarter to 30 in the third quarter. That means we had to fire another 3. No hiring going to happen. You'll never have hiring and firing in the same period. Makes no sense. And our ending inventory is the excess production of 220 when you take 7,200 minus 6,980. Your double check. Is that less than one worker's output? Yes, barely. So to get our 30 employees, you must have calculated 29.0 something probably, right? 29.1, rounded up to 30. So that last employee, most of his or her production is going to be excess. But you want to make sure we're not short. And then finally, I'll go ahead and finish this. 220. 11,780 is our net demand. As demand jumps in the last quarter, 11,780 that we need divided by 240 per worker. How many workers do we need?
50.
50, 49 point something, right? Goes up to 50. Now, 50 times 240
It's 11,780.
is a what?
11,780.
11,180?
No, 11,780. That's what you did.
You said
11,780.
11,700, it's exact?
Yes, exactly.
Oh, okay. That's right?
Oh, wait. You're asking about that. That's 12,000.
That's 12,000.
Yeah, that's 12,000.
Yeah,
I thought you asked about the other.
I've already got the other.
Uh-huh.
2 people at least have said yes on that. So yeah, it's 12,000. 50 times 240. Actual production is 12,000. So we're overproducing slightly. And again, we end up overproducing 220 units. But before we get to that, we went from 30 employees to 50, so we're going to have to hire on 20 more. Not firing anybody. And our ending inventory is the 12,000 actual production minus 11,780. 220 ending inventory. Again, your inventory numbers are relatively low compared to your demand numbers, because it's the chase plan, we're adjusting the output, to try and match output to demand every period. We do have ending inventory, because we round up the number of employees and work them to the full productivity for this particular plan. And then we can cost that out if you want to. I might ask something like, what's your labor wages going to be in the first quarter? Something like that. And if I ask that question, you need to figure out how many workers in the first quarter times what do they earn. So if I ask that, wages, we did the pre-calculation, every worker makes $2,400. So in the first period, you'd have 40 times 2,400 per worker equals 90-some thousand? I'm guessing. 96? Well, I got it within 10,000. If you didn't pre-process, you could just think. If I had to come up with this person's paycheck, I would take the 40 workers working 60 days times 8 hours a day times $5 an hour, and you'd come up with 9,600. Do we have hiring and firing costs? I'll put a few of those in there and then we're done. They say we had to hire in that period. Hiring cost is $100 each. $100 times 10 hired is 1,000. No firing costs. And do we have an inventory cost given here? $5 per unit per quarter. So our inventory holding cost, carrying cost, the same thing. 100 units at the end, we'll base it on that, and $5 a unit, $500. And similarly, if I asked you to give me a cost for the second quarter, don't calculate the cost for the first quarter. Just do the second quarter one. Give me whatever I ask for as quickly as you can. You do the same thing in the second quarter, except we have firing costs instead of hiring costs, and firing is $200 each. So you'd have 7 times 200, you'd have 1,400 down here. No hiring costs, and you calculate everything else essentially out the same way. So that's our chase plan. Just stay right next to it. And change colors. Not that I think that's going to help much any. But we'll move to a level plan. Same numbers. 10,000, 8,000, 7, and 12. Still going to have 500 beginning inventory in the first period. 9,500 net in the first period. But now we're going to do a level plan, which means figure out the employees you need to produce your total net demand for the plan over the entire 4 quarters. So how would we do that? Add up the output per quarter for 1 employee. That'll give me my output for a year for 1 employee. 240 times 4, 480, 960. That's my annual output for an employee. And my annual wages would, it looks like 9,600. 4,800 plus 4,800. 2,400 times 4 gives me 9,600. Once I've done it per quarter, I just add them up to get the total for the year. So, the number of employees for a level plan should be based on my total net demand in the entire plan divided by the output from 1 employee over the entire year. I'll take my gross demand, haven't figured that out yet, right? Gross demand for the whole year is just add them up. 10,000, 18,000, 25,000, 37,000. That's the gross Don't forget your beginning inventory. Minus 500. I need to have enough employees, there's my net demand, 36,500. I need enough employees on the payroll all year long so that I'll produce at least that much. Divide by what one employee gives me. One employee gives me 960 units. Comes from adding up 240 across 4 quarters. And this is going to be 30 something, I think. 38, 39. Somebody do that math. You can't all leave on me, I need someone to work calculators. 30 what?
3802.
38.02. Now we get to, what are you going to do about that .02? Really? Are we going to round that up, Dr. Shakura? And yeah, we're going to round it up. It's just, we don't want to plan to not produce enough. Although .02, we probably could leave it off at 38 and let it go. But we will just, yes, we'll go to 39 employees. And we're going to overproduce almost 960 units. Because that .98 of an employee that we added by rounding up, that .98 of that worker's year is going to go to overproducing. Round up, round down, real world, does it really matter? We don't know if our forecasts are 100%. We don't know what's going to be going on. Our productivity is really going to vary a little bit. Probably doesn't matter if you round one way or another. But I want everybody to get the same answer because it's going to be a test. So we'll just stick with that particular rule. So 39 workers. It's a level plan, so we set it and forget it. 39 workers, and then from this point, it's just going through the quarterly calculations like we did before. I start with 30. I'm going to 39 workers. I'm jumping ahead here, so that means I have to hire 9. But in a level plan, since you don't change after the first period, there won't be any more hiring or firing, because you're going to stay at 39. Our actual production now, and because every quarter has the same number of days, and every quarter has the same number of workers, I calculate actual production once. And it'll fill across. It's 39 times, it hasn't changed, that in one quarter, one employee makes 240. 39 times 240 is 9,360?
Yes.
And what in the world does that mean as far as ending inventory? I needed to produce 9,500. I'm only producing 9,360. So this is a case where a plant starts off with negative inventory at the end. Why have we gone negative? Because this 9,500 net demand is a little more than the average net demand over the year. So with a level plan, we'll underproduce during peak periods, overproduce during slow periods. So 140 negative is our ending inventory for the first quarter. You just carry that over. Minus 140 is your beginning inventory for the second period. Do the same math, 8,000 minus a negative 140. Our net demand is 8,140. 8,000 of that from new sales, and 140 to satisfy the prior period shortage. We're going to be producing 9,360 because the output per quarter doesn't change. If it did, you would take the 39 workers times the output for the second quarter, and so on. But it doesn't here. And here we see we start building up inventory because we're in those slower periods. 9,360 produced to satisfy demand of 8,140. Leaves us 1,220. Is that a guess? Somebody?
That's right.
Yes? Okay, thank you. That 1220 carries over to the next period, leaving a net demand in the next period of 5,780. We're going to produce 9360. This is the slowest demand period. It's when our inventory is going to peak. So our inventory is going to go up. Let me do the, trying to do this in my head. It could be 3,000 something. What is that?
3580.
3580. Peaked our inventory. We had to do that because now we're heading into busy season, and our 360 isn't going to satisfy what's demanded, 12,000 in that next period. But because we built up inventory, 3580. Running out of space here. 39 employees, and move down here a bit. My actual 0 to 8? No. Yes. 8,420 is my net? Yes, thank you. I'm producing 9360. And the difference between that is, what, 940? Yep. Because, remember, we got an extra 0.98 workers. That extra output, 940. Just under the output for that employee for the 1 quarter. There's my check. And I know that it looks good. Doing the cost would be done the same way. I don't think there's any reason to redo the costs here. You would have hiring costs only in the first period. Nowhere else, no hiring and firing costs anywhere else. You would see your inventory costs go way up because these positive inventory numbers would be charged at $5 a unit. The negative inventory number, back orders are charged at $10 a unit. So we could do, let's do 1 period. Our wages would be 39 times 2,400 would be 2,400 less than this, 93,600. 39 times, again, in each quarter only making 2,400. Hiring, 9 workers times 100. No firing costs. And our holding costs are going to be 140 times 10. Anybody? 0. What do you mean holding costs? It depends if I've given you, did I give you 2 rows for it here? No, I gave you just basically on this worksheet 1 row for ending inventory, so we put a negative number there. And I'm only giving you 1 row for inventory / back order cost. So we put both of them on that 1 row. Every back order costs $10 a unit. So it'd be 140 times 10. Not a negative cost. Or you wouldn't carry the negative down. It ends up being a positive cost. That equals 1,400. You can compare that to your holding costs for the first plant, and then when you go on out here, your holding costs are 1,220 times 5, 3,580 times 5, 940 times 5. And you would see your holding costs go way up, but your hiring and firing costs go down. And I am not going to make you on an exam do the whole damn thing and cost out the whole thing. Do whatever you need to do to get the number I'm asking you for, and then be done. So, I'm not going to be asking you for a number from the last period. Read the problem, see what I want, give me the answer that I need. Questions on those? If you got questions, you'll be able to review this video, all those other things at the website that you'll be able to use. At this point, since I don't see any questions from my audience and I can't hear any of you out in online land, we'll move and just do a few inventory examples. In this handout, It tells you the kind of problems you're going to see. And it gives an example of each. And then it asks some more challenging questions than the lecture in particular asked. It'll answer more challenging questions that are also presented in that handout on inventory problem examples. So really, if you want to do better on the inventory part, besides watching this, you should redo that inventory handout. If anything that I've written in the handout makes no sense, you know my email address. You know my phone number. You can write or call. So our inventory models, only 3 that you're going to have to do in any one exam, though the book presents several other ones, trying to keep things a little tighter here. 2 fixed order quantity models. The basic fixed order quantity, that's that introductory model with all the simplifying assumptions. A fixed order quantity model with a service level. And then a single period model. And these 3 little blurbs up at the top tell you which one, what kind of a problem is going to be this particular type of model. So the basic fixed order quantity, if I ask for an order quantity and a reorder point, no indication of variability of demand or service levels or anything, that's your basic fixed order quantity. If I ask for a order quantity and a reorder point, and I talk about variability of demand, I talk about a service level, that's the second one, the fixed order quantity with a service level. And then if it's something that has limited demand life, I talk about the cost of throwing away any extra stuff. Then we're looking at the single period model. Marquis, the question I can help you with?
He's explaining something.
Okay. Let me know if you need more help.
Okay.
So 3 example problems here, several questions at them. The very first one, reading through, a retailer deciding how to order one of their best-selling items, operate 52 weeks a year. Demand for the item is fairly uniform and constant throughout the year. That sounds like basic fixed order quantity. The wholesaler expects to sell 13,000 of these in the coming year, pays $3 a piece for them, regardless of how many they order, so no quantity discounts. Wouldn't expect to see that. We're not going to be doing quantity discount model. The company figures annual inventory holding costs per unit based on a straight 15% of the unit cost. So here's where the holding cost is not given directly. You simply take the percentage given times the unit cost. Every order placed costs $100 in administrative overhead. Lead time from the manufacturer is known to be 4 weeks. So here's an example where the small time unit is going to be weeks, not days. Little d is going to be the demand per week then, although it typically comes from day. Don't worry about it. If everything's given in weeks, we can work this in weeks. They told us how many weeks there are in the year. They tell us lead time in weeks. So we're going to be able to solve this doing things in time units of weeks. So what's the economic order quantity? What would be the reorder point? There's no variability of demand. It's the basic fixed order quantity. We go to the formula sheet. For both the FOQs, our order quantity is the same formula. It's given. You'll have it. On the exam, the basic fixed order quantity with no variability of demand is the simple reorder point formula. R equals D bar times L. So for A, all you need to do is find the values of D, S, H, lowercase d, and L, and you plug and chug. And we can pull most of these right out of the problem. What is big D?
13,000.
What's that?
13,000.
13,000. What page am I on here? That's what I say the annual demand. They expect to sell 13,000. Big D is for the whole year. D is demand. D, S, what is S here? Comes from the word setup.
Use 100.
So it started in a production environment, but it applies to the cost for every order that is made. So it's $100 here, right?
Yeah.
Every order placed costs $100 to place the order. That's the cost per order, that's S. What else have we got? I want to know what H is. Here's an example because it'll give you a percentage of the unit cost, where the one formula for H, lowercase I times C, that's what's applied here, where I is that percentage, and C is the cost per unit. I see students mix up S and C all the time. C is the cost for one unit to buy it or to make it. So in this case, it's 0.15, the 15%, times our unit cost of $3.
Yeah, it's 0.45.
45 cents per unit per year. That's what H means. Cost to carry one unit 1 year. So I got everything I need to figure out Q. Let's figure out what R is. I need lowercase d, and I need L. So the small d is demand per whatever time unit you're planning in. This one, everything's in weeks. So we'll just leave it in weeks. I've seen students try to calculate that in days. Don't need to do that. Keep everything in the same time units and we're good. And so they don't tell us that, but they tell us 13,000 in the year demanded over 52 weeks. You can figure out what it is per week. 13,000 divided by 52. $20-something, 200-something rather? 250?
250.
Exactly? How convenient. Our demand per week is 250. The lead time, same time units given in weeks, it tells it's 4. L is lead time. 4. Got everything we need to solve this first problem. Plug and chug. So Q, and I will need help calculating. I don't have the answers. I don't know what I do with my answer sheet. It's going to be square root. Don't forget the square root of 2. 13,000 times 100 divided by 0.45. R is going to equal 250 times 4. Oh, I can do that one. Our reorder point is going to be 1,000 units. And I've seen students call a reorder point $1,000. No, it's units of inventory. Our reorder point is how many units are left when we place an order. I've seen students call that dollars. It's not dollars. Units of inventory. Q, I can't do that in my head. I have trouble doing that with a calculator. What? Somebody give me an answer.
Rounded up, it's 2,404.
2,404?
Yeah.
I'm getting an amen. 2,404 rounded up. So 2,403 and something. We just round up. And that's your inventory policy. When inventory drops down to 1,000 units, place an order for 2,404 more. This order quantity minimizes our total costs. This reorder point makes sure that we've got enough inventory when we place an order to satisfy demand over lead time. 250 a week times 4 weeks. But I'm not done, right? Definitely you'll see this. How about the next one? So this was A. B, what's the total cost as a result of this policy? Well, we go to the formula of what's the total cost formula. It's probably the one that says TC, the total cost. 3 components, D times C. What do we have to pay for that? That's the purchase price. Second component, is our ordering cost. D, our annual demand divided by Q, how much we order each time, will tell us how many orders we place in a year. and multiply times S, the cost for one order. So this second term is your ordering cost. Last component, Q over 2 times H. Q over 2 is your average inventory. Average inventory level throughout a year by the cost to carry one unit 1 year. So it's just plugging and chugging because we got everything already. D is 13,000. It costs us $3 a unit. That's C. Plus D over Q. I've got to get 13,000 in a year. I'm ordering 2404 each time. That'll give me an average number of orders per year times my ordering cost of S equals 100. And then Q over 2, 2404 over 2 times my holding cost. We figured that at 45 cents. Okay, so I can get the first one in my head. That's going to be 39,000. Going to be our purchase price. I can't do either of the rest of these, so I guess I could break a calculator out, work it myself. Or I can count on you guys. What's that second term? Lost Casey? That's slacker. Tell him I said so. What do you got for the second term? What is this? Anybody?
540.8.
540.8?
Yeah, 543.77.
540.77?
Yeah, if you're right, it's decimal places.
Yeah, it's dollars, so we'll go out to cents. And then the next one. We'll find something interesting. Calculate the next term. What's that?
540.9.
540.9. Well, that's pretty close to the second one, right? 0.90, I don't know if you round it up or whatever,
No,
but
it's 540.90.
0.90?
Yeah.
Okay. And then you would add those guys up, and you get 40,000, 81 and 67 cents, it looks like. And after a while, you can stop worrying about the, or 60, so you can stop worrying about the cents after a while. That doesn't matter. You may notice, as we calculated this, that the second and the third term costs are almost identical. There's a check for you when doing this, using the EOQ formula. Mathematically, if we put in an order quantity out to the decimal place that you calculated, these two terms will be equal. That's the nature of this problem, where your annual setup costs and your annual holding costs are the same. That's where the EOQ is. They're a little different because we rounded to get this number. That's why they're off by a few cents. There's a check to make sure that you're doing things right if you have to calculate a total cost. What's the last thing I want to know here? But the vendor, being sneaky to us, offering a $250 discount. It's very realistic. Vendors always want to sell more in an order. That's less order processing for them. They get more economies of scale when they're producing and pushing more stuff. So they're offering a $250 discount per order if instead we order 5,000 units each time.
Instead of 1,000?
Instead of what?
Instead of 1,000?
Instead of 2,404.
Oh, okay.
That's our order quantity we calculated. Now they're throwing something into the mix. We're not giving you a unit discount, but we'll give you an order discount at $250 an order if you change your order quantity to 5,000. Should we do that? Well, I know if I push my order quantity to 5,000, this formula will go up. But I would subtract something off of that, $250 an order. Should I do it? Should I not do it? The only way to figure that out is, well, what would be the total cost under their proposal? And compare it to the total cost we've got here already. So C, our total cost is going to be similar, but different. It's still we'll leave D times C alone. That's there. The discount per order could be handled two different ways. Here we have a cost per order, S. And what we could do is subtract that discount per order off of S, because you're reducing the cost per order. You could do it that way, or you could add a fourth term. That would be B over Q, number of orders per year, times 250 and make it a negative term as a discount. Either way, it's going to work out exactly the same way. So our setup cost is 100. I'll do it this way. I'll keep it in three terms. Plus D over Q times our setup cost minus 250. I can do that because the 250 is a cost or discount per order. Then we're back to the Q over 2 times H. 39,000 would be our basic per unit purchase price. Now my setup cost was 100. Subtract off 250. Now I've got a minus 2. We still have a demand of 13,000, but my Q has changed. They're saying you must order 5,000. And for every order we place, we end up saving 150 bucks. It's 100 our setup cost minus the 250 discount they're giving us. Plus Q over 2, now Q is 5,000, so that changes, times 0.45. $39,000 doesn't change. Minus 2.6 times 150, 390?
Yeah.
Yeah? Hey, good for me. Minus 390. Our holding cost of 2,500 times 45 cents, 1,200 bucks or something. 11 what?
11.25.
11.25. Point anything?
Nope.
No.
No.
Huh. Okay. And when we do that, we get 41, 125 minus that. You get, well, add them up. Can't do that in my head.
39,735.
Looks like you might save a little money, right? 39 what?
39,735.
There's a question mark at the end of what he said, so somebody, okay. That's what it is. And I could have looked before, I was looking before and seeing, you know, here I was at 1,080. And I could, by adding these together, I could say it would be less than 1,080. So in this case, it would make sense to take them up on that. You'll be carrying more inventory. On average now, 2,500 instead of 1,202. But that extra carrying cost will be offset by that discount that they give us per order. And there's no short way to answer that question. You got to compare total cost. There's another example of that in the inventory model handout I was showing earlier before we started. So your situation can throw all sorts of boomerangs at you to ask you questions. Any questions on that? If you can just do the Q and the R, you're going to get most of what I'm looking for. But I'll throw a couple other things in there to make you think. 19, this looks like, I think, problem 19 out of the back of the chapter. It's on the next page. It's the last page of problems. The annual demand for a product is 15,600 units. The weekly demand is 300 units with a standard deviation of 90. So there's a variation of demand. They give us a cost to place an order, lead time, carrying costs, and I asked for an order quantity and reorder point. So I know it's a fixed order quantity model that we're going to be looking at. but it's the second one with the service level, because it talks about variability of demand, and the question talks about a 98% service level. So we'll attack this. The formula for Q does not change. For both of those fixed order quantity models, Q is the same formula. Am I asking for it? The best order quantity, give this restriction. I think I'll leave some of this in place, I might need it. So again, we need to take the data given and throw them against the levers. Our annual demand, big D, is given as 15,600. S, the per order cost, is given at 3120. What a weird cost. You'll see that this is convenient. The numbers work out to nice round numbers. This is out of the book. H, the holding cost, and they give it to you directly here. The annual carrying cost per unit, carrying cost and holding cost, same thing, is 10 cents a unit. Our time unit demand, they tell us that. The weekly demand, so we're back to weeks again, is 300 units, so it's given, we don't have to calculate it. And if you divide our annual demand by the weekly demand, you'll know how many weeks in the year there is in this planning problem. Don't need to worry about that though. The lead time is given at 4 weeks. Common lead time here in these problems. I got everything to figure out Q, but my reorder point, I got to change that. There's the average demand over lead time. Now we're going to add some safety stock to get to a higher service level than 50%. So we use the longer R formula. This is given as Z times sigma L. So I've got almost everything I need. I have everything I need for the old formulas. Now I need to come up with Z, and I need to figure out sigma L. Let's start with Z. Well, that comes from our service level stated in the question. A, find out what do we need to do to get a service level of 98%. Just that at 0.98. Go to the Z table, find the Z value associated to the closest probability to 0.98. So you'll have this table on the exam. It gives us more exact numbers. Go through all those probabilities, find the closest to 0.98. I've got 0.9798, 0.9803. We'll go with the 0.9798. And right next to it is a Z of 2.05. For the online students, you'd find the same answer if you use the table in the book, but you can also just take this table here from the handout, print that out, and use it on your exam. So I've got a Z. Last thing I need, is that right?
I was just gonna say, so the 9803 wouldn't be closest, or is it just because you
Well, it's just 0.9803 is the 0.0003 away, and the 0.9798 is 0.0002 away. It doesn't really matter. You know what? If you gave me either one on an exam, you're fine. This is not table reading class. Give me either one, I would be fine. But I explain why it would be closer. It's a little more obvious using the table in the book. Now I have my Z. I need my sigma L. And we go, is there a formula for sigma L? There sure should be. Sigma L, the standard deviation over lead time, you can't just add up your standard deviation per week. Oh, I didn't even put that down. I've got sigma, we use the little d notation for that, even though we're working in weeks. And the problem says, I keep flipping pages here.
It's 90.
90? So we need to know what's our standard deviation over 4 weeks. You can't add up 90 over 4 weeks. Statistics say, nay, that's not what works. You can add up the variance over 4 weeks. And so that's what this formula does. Take the square root of L, take the number of weeks of lead time, multiply it times the variance per week, which is sigma d squared. Standard deviation squared is the variance. Then you can add up the variance over the 4 weeks of lead time. You'll get the variance over lead time. Take the square root to go from the variance back to a standard deviation. So it's equal to the square root of 4 weeks of lead time times 90 squared, 8,100 times 4, I don't know, someone do that. 24,400 square root. 180? Exactly? Yeah, did somebody else get a 180 exactly? Yeah.
We're going with it.
We're going with it. You won't have him to go with you on the exam. You're going to have to, 180. Yeah, square root of 4 is 2. Yeah, that makes sense. 2 times that square root of 90 is oh, it works. Yeah, so sigma L is 180. Now we got everything we need to fill it in. Q is equal to 2 times this nice convenient 15,600 times our order cost of 3,120 divided by a nice small 0.10 holding cost. Very low holding cost drives Q higher. So that makes sense. In here we'll carry more because it doesn't cost as much to carry. And we plug and chug that number. You get a nice round number, don't you?
3120.
What's that, 3120? Exactly, again. This is a contrived problem. You'll never come up with exact numbers like this in business. The reorder point, our weekly demand of 300 times 4 weeks, it's going to be 1,200, plus we're going to add 2.05 standard deviations of demand over lead time, which is 90, 1,200, 1,380 something. What did I screw up?
Why'd we put 90 in there instead of the 180? Oh, either on. Okay.
Times, oh, because I put the wrong number in. Thank you. Sigma L, not 90, 180. Thank you. So that's 360, 1,500, 1,500, 1,600? 50 what?
69.
69, 1569, yay, I guess the head's nodding. Where the hell am I? 1569. Is that an exact number too?
Yeah.
Okay, how nice and convenient. So, there's our reorder policy. Keep track of inventory when it drops down to 1,569 units. Place a new order. That's more than we need to cover average demand, but we're going to place that order here so we have enough inventory to carry us when demand is more than average over lead time. When you hit that inventory level, place an order for 3,120 more, and then 98% of the time while you're waiting for that order to show up, 98% of the time you'll have enough inventory to satisfy demand over lead time. 2% of the time, 2 out of every 100 orders, You'll just hit a high demand lead time period, or you'll run out, won't have quite enough. And have to satisfy that with your next order. B says, here's something I threw at you in class, right? Let's say that, and for online, I didn't throw it at you, but you would see it in that inventory example handout. Assume that, or what is the case if the vendor says, sorry, you can't order 3,120. You instead have to order in multiples of 750. We only sell these in case quantities, and each case has 750. What are you going to do? You can place an order for 3,120, and they'll keep sending it back, because that's not a multiple of 750. You can draw that total cost curve as a function of Q. And it's talked about in the lecture and the reading and everything. A very small Q, your total cost is high. As you increase Q, it tends to drop off to some minimum point, and then beyond that minimum point, higher order quantities start pushing your total cost up higher again. We have already calculated that minimum point at 3,120. I can't do that. I have to order in multiples of 750. So what you want to do is evaluate your potential order quantities closest to your optimum Q on either side. 750, 1,500, 2,250, 3,000. 3,000 would be one. So there's a potential right here, and we're an order quantity of 3,750. You got to go to either side. You can't order exactly what you calculated. So again, it becomes a total cost thing. Which one should we go to? So this 3,000 is closer, but it's a nature of the problem that your cost curve climbs faster to the left than it does to the right. And I just do this by hand, so I can't visually look at it or anything. So the way to do this would be to calculate your total cost at both of these potential order quantities. We do that up over here. We're doing total cost at Q equals 3,000, total cost at Q equals 3,750, and compare them. First term would be D times C. I didn't tell you what C is here, though, did I? I tell you the unit cost? Not here. How can we do this? You can just recognize that, well, D times C is going to be the same in either of those total costs, right? It's not going to change. So we'll just put it in there as an unknown constant. What's going to change are going to be your other two terms as Q changes. So you just do D times C and not worry about it. Worry about the other two. So at 3,000, it's going to be your annual demand of 15,600 divided by 3,000 as an order quantity times your ordering cost of 3,120. And then your holding cost will be Q, 3,000 over 2 times what, 10 cents, right? And you would just compare these two terms and add them up to see which one is lower. At 3,750, your ordering cost will drop because you're ordering more each time, so fewer orders, but your holding costs will go up. How does that work out to? 15,600 divided by 3,750 now, times this weird 3,120, 3,750 divided by 2 times 0.1. I'm not even going to go through this. I'm running out of time. I do need to get to another class here in half an hour, but you can punch in your numbers. The numbers, the totals will be pretty close. Near your optimum Q, that total cost curve doesn't move a whole lot when you go left or right. They'll be pretty close. I'm suspecting the Q of 3,000 will give you a slightly lower total cost. Figure that out yourself. You should come up with pretty close numbers. That's how you would do it, though. Are you ready for the last one? Sarah has had enough. She is leaving. That's okay.
I have to go babysit, I'm sorry.
You have to go babysit.
Yeah.
I have to too, I have another class. Okay.
And I said before coming to our class.
But there are OSCM majors, I don't have to babysit them too much. Sometimes these guys, I'll tell you. Last problem, so have a good time babysitting, Sarah, don't take this out on them, please.
Okay.
Okay. Our last one, is a news vendor. Remember I said the single period model was first studied with this news vendor idea. Selling the paper, San Pedro, let's came out of the book, San Pedro Times. You go to the publisher, buy the day's paper for 25 cents a copy. When you sell them for $1. At the end of every day, any leftover copies are worthless. They go in the recycle bin. We have an average daily demand and an average standard deviation. This one is a single period model. Every day's ordering decision is a new single period because leftovers from yesterday are no good today. Q goes out the window, R goes up. We don't need a reorder point because placing one order for one unique time period, not something that is used continuously and replenished over time. It's not a replenishment model. So it's a single period model. We go back to the formulas and I even tell you the single period model is based on that critical probability inequality. We're looking for the highest order quantity so that this thing holds. And our order quantity, called Q star in this case, is kind of like a reorder point from before. It's our average demand, and this time for the single period, not over lead time. It's our average demand mu sub, what do we call it, mu sub D. So the only problems we're working are where demand is represented by a normal distribution. And then we're going to add or subtract, depending upon whether Z is positive or negative, some number of units to or from the average based on Z. Once again, it's a normal distribution. We're looking for a probability times sigma D. Sigma D in this case, same as before, it's the standard deviation of demand for this one time period. Let's see what we have here. So CU and CO are our costs of under ordering and over ordering. If you under order, that means that you didn't order enough, someone came and demanded a unit, you could not sell it. Lost profit is under order. And it's marginal. All of this is marginal analysis. So it's the lost profit per unit. CO, the cost of over ordering, is the cost when you've got one unit too much and you've got to throw it away, or maybe perhaps you can scrap it and get some salvage value, but you still lose. So this is your salvage or scrap cost. Again, per unit. So we can figure out what these guys are by looking at the problem. The potential profit per unit, you had business 100, you should be able to figure this out. What's the profit made on each newspaper that's sold? Oh, you guys should all be yelling at me.
I didn't hear you. What's that?
What is the profit for each newspaper you sell?
Just 75.
75 cents, because you buy it for a quarter, sell it for $1. The difference is your profit. 0.75. Your salvage or scrap cost, the 25 cents you paid, minus nothing, because you don't get anything back if you have an extra one. You have to throw it. So it's 25 cents. If the printer paid him 5 cents a copy to take it back for recycling, well then his CO would be 20 cents. 25 minus the 5 cents he got back. But he gets nothing back. So it's 25. And we can throw these guys into this critical ratio, critical probability, inequality. CU is 0.75. 0.75 plus 0.25. 0.75 over 1 is 0.75. So this ends up being a probability we'll look for in a Z table. It's greater than 0.5. Your probability of 0.5 in a Z table is associated with a Z of 0, with ordering exactly the average. But we're going to be ordering more than the average because this is higher than 0.5. Why would we order more than the average or expected demand? Because we're chasing a profit of 75 cents at the potential loss of a quarter. So I talked about this in class about if you're a gambler. You know, would you do that? Would you put a quarter down at the 50-50 kind of chance of getting a buck back or losing your quarter? Yeah, you'd start doing that. But the more and more units that you order above the average, the lower and lower probability you're going to sell that last unit. And so this thing tells us, keep pushing your order quantity higher than the average so that the probability that demand is less than what we sell, what we buy, the probability that we'll have something left over is still less than 0.75. We've talked about that a lot in the classroom. I don't know how much I talked about it in the online lecture, but because our potential profit is more than our potential loss, we'll order more than the average demand. Kind of a gambling idea. So what do we have to do? We need to find out what Z is, because we got everything else. The problem says my expected demand, mu D, the mean of demand is going to be 250, and my standard deviation of demand for any one day, 50. My demand for papers goes up and down throughout time, and each day with an average of 250. So I need my Z. So Z equals, again, what the hell does that equal? Well, we go to the Z table, and we're looking at 0.75, 0.75 in the Z table as a probability. So it's in the G of Z column. In this case, you want to find the closest one, the biggest probability that does not exceed 0.75. Again, if you give me the next one up, I won't really care. But the idea is we want to make sure that inequality holds. So we look for the biggest probability that does not exceed 0.75. And I have a probability of 0.7486. And I see that with a Z of 0.67. You guys see that? Probably 0.7486, that's the biggest one that does not exceed 0.75. Therefore, finally, my Z is 0.67. That's it. What it's saying is I'll order the average demand plus 0.67, 2/3 of a standard deviation of demand. I'm going to order more than I expect to sell on average, as I'm chasing that profit that's 3 times my potential loss. Plug and chug. We're almost done. And we'll make it to my next class. 250 plus 2/3, 0.67 of my standard deviation of demand, which was 50.
58.5.
What's that to what?
Oh no, I left the 0. Never mind.
280 something, right?
283.5.
283.5.
284.
You round up or round down. Again, this one, we would say round down, because we're trying to keep this less than or equal to, so you'd round that one down. If you gave me 284, 283, I don't care. Can you get me to this point? And that's it. So on average in this problem, you're gonna have stuff left over because you're ordering more than the average every time. But the cost of those leftovers, relatively minor compared to the cost of the extra profit when you do sell the extra things that you ordered. All right, well, you guys have done well. Hung in here for almost 2 hours. Yes, my in-class people have been here for 2 hours. You guys out there in video land have not. You guys have a good weekend. I wish you good studying. I wish you success on the exam. And I wish you not too much drinking or hangovers because the exam's coming too soon. So.